Good morning, Lay-Cee. So this is that question that we got started on yesterday that I needed a little more time to look at and have done so. So it says, according to the U.S. Census data, in 2007, there were approximately 37 plus million U.S. residents in that age group. Of these, 56% were students and 53% had jobs. 22% were students and had jobs. So in 2007, you picked a person aged 16 through 24 at random, and you asked two yes/no questions, whether the person is a student and whether the person has a job. So the first thing we wanted to do is construct a joint probability table for this problem, label it in a reasonable way, and so on. So when I started to approach this problem on my own, I decided, I need to organize this in a Venn diagram. Venn diagrams always help me get this kind of problem organized. Now, when you make a Venn diagram, you always start with the intersection, with the shared probability. And in this case, there were 22% of the people who were both students and had jobs. So that intersection here is 0.22. Now then we knew that of these people in the United States, 56% were students. So that means that within the students' circle, we must have 56%. Well, we've already accounted for 22% of it, so we're going to need to take that 56% and subtract the 22% that is already present there. So 0.56 minus 0.22 will give us the proportion who are just students that don't have a job, and that would be 0.34. And we can use the same line of thinking to figure out what proportion are just those who have jobs and are not students. And so that comes from knowing that 53% had jobs. 22% is already accounted for in that circle. So to find what proportion have only jobs and are not students, we're going to need to take that 53% and subtract that 22%. So there's a 31% who have only a job and are not students. So now if we add up all of these numbers, 34%, 22%, and 31%, they add up to 87%. So where are the other 13%? Because of course we know this represents 100% of the people in the year 2007. Well, the other 13% must be out here, those people who are neither students nor have jobs. So now we can make our joint probability table. We're going to have students and not students like we started yesterday. And jobs and not jobs. So if we start with the jobs and students, the top left-hand corner, that's the 22%. That's the 0.22. I don't know if it matters if you express them as decimals or percentages. If you go to the top right little corner of this table, that would be those who have a job and are not students. So those who have a job and are not students would be this 31%, because they're in the job circle but not in the student circle. The bottom left-hand corner would be those who do not have jobs and are students. So that would be this 34%, do not have jobs and are students, because they are in the student circle but not in the job circle. And then the bottom right corner is those who do not have a job and are not students. Well, that would be this number here that are neither. So this would be 0.13. And again, you're going to notice that all of those proportions or probabilities add up to 100% or 1. So now our questions can be answered using our joint probability table. In B it says, what is the probability that the person answers that he or she is not a student and does not have a job. Well, that of course is our 13%. It's the number in the table in the row labeled not J and in the column labeled not S. And it's the number in the Venn diagram that is in neither one of the circles. So this probability here is our answer to B. C says, if the person answers that he is a student. So this is a conditional probability. If the person answers that he is a student. So that's like saying, given the person is a student, what is the probability that he does not have a job? Not have a job. So you've learned a probability formula for a conditional probability. And I'll put this up here in the top right-hand corner. So with a conditional probability, you always take the probability that he is in both events. In this case, both does not have a job and is a student. That's what that intersection means. And you always divide by the given. So in our case here, the probability that he does not have a job and is a student is our probability in red. It is our 34%. And now I see that I read the question wrong. The question said, if the person chosen is a student, then what is the conditional probability that he does have a job? So not that he doesn't have a job, but that he does have a job. So I need to make a correction here. So again, we need to find the probability that he's both. Well, the probability that the student both has a job and is a student is the 22%, or 0.22. And then we have to divide by the probability he is a student. Now that's total probability that he is a student, and we were given that in the problem. It was 56%, but that's also the sum of the student column. So we're going to divide by 0.56. And so the probability that if we know the person we chose said that they were a student, the likelihood that that person also has a job is equal to about 0.393. So now on to D. D says, what is the probability that a person is a student or has a job? Well, that's another probability formula that you have learned, and I'll advance to the next slide to do this one. So the probability the person is a student or has a job. So in an or situation, you've learned to use this union rule. The probability is a student or has a job is the probability of S union J. In this case, you've learned to add their probabilities together, but then you must subtract the intersection. Because if you don't, then you've counted those that were both students and had a job twice, because they were a part of the student probability and they were a part of the job probability. So we know from the given information in the problem that the probability that the person selected is a student is 0.56. And we know from the given information that the probability the student has a job, or the person has a job, is 0.53. We can also get this from our table or Venn diagram, but these were given right in the problem. And then we know the probability that the student is both was 22%, or 0.22. So we have to subtract that, because again, that 22% was both a part of the 56% and it was a part of the 53%. We don't want to count it twice. So the probability that the person selected is a student or has a job is equivalent to 0.87. You'll also notice that it's the sum of the probabilities within the circles in our Venn diagram. I hope that helps, Lacey, but be sure to ask me questions if you have any.